Alright, so in this video I'm going to do some more examples of implicit differentiation problems. I've had quite a few emails, people requesting to see a few more examples of this. Alright, so again, the basic idea is in these problems you're taking the derivative with respect to x. The only thing you have to remember is basically when you take the derivative of something involving a letter other than x, typically y, you'll just need to tack on a dy dx, and mechanically that's all that happens. So suppose we want to take the derivative of x cubed plus y cubed equals the product x times y. Well, on the left side, when I take the derivative of x cubed is simply 3x squared. The derivative of y cubed, this is where we have to be a little careful. I get 3y squared, kind of using my same, the same normal procedure, but in this case I have to remember to tack on this dy dx term. So you cannot forget that part. And on the the right side, I recognize, okay, well, I have a product, so I'm going to have to use the product rule on this. So if I take the derivative of the x, I'll get a 1, leaving the y part alone. And notice you don't tack on a dy dx because you didn't take the derivative of the y piece just yet. And then you put a plus in between, and now I'll leave the x part alone. Well, the derivative of 1y is just 1, but again, here you have to remember to tack on your dy dx term because we took the derivative of something involving y. Alright, at this point, basically what you want to do is simply get all your dy dx's on the same side. So I'm going to leave my 3y squared dy dx on the left. So I'll have 3y squared dy dx. I'm going to move my x times dy dx term over by subtracting it. So I'll have minus x dy dx. And on the right side, I'm just going to get everything that doesn't have a dy dx attached to it. So my 1y is still just hanging out there like it was before. And now I'm going to have to move the 3x squared term over to the right by subtracting it. So minus 3x squared. And the point of putting all your dy dx's on the left side, or on one side or the other, is now that you can factor that dy dx term out. So in the parentheses, I'll need the 3y squared term, the minus x term. You're basically done with the right-hand side. And in all of these problems, you're trying to solve for dy dx, so the last thing you have to do is simply get the dy dx term by itself. And we do that by dividing by this whole quantity, 3y squared minus x. So on the right side, you'll have y minus 3x squared over 3y squared minus x. And that is now your solution. Okay? So again, the only thing you have to remember, and this is kind of a basic procedure for these problems, when you take the derivative of something involving y, tack on your dy dx term, and then simply put them all on the same side, factor your dy dx out, and basically divide by what you're left with, and you'll get your solution that way. Maybe let me do one more problem here. So I've got x squared times y plus x times y squared, and we'll make that simply equal to 3x. Alright, so again, I've got to do the product rule now twice on the left side. So if I take the derivative, I'm going to do the x squared y piece first. So the derivative of x squared is 2x. I'll leave the y term alone. Plus, now I'll leave the x squared term alone. The derivative of y, again, is 1 dy dx. So that's all just the first part with the product rule. And now I'll have to do the same thing with my next term, my x times y squared term. So again, if I take the derivative of x, I'll get 1, put this stuff in parentheses. If I take the derivative of x, I'll get 1. I leave the y squared term alone. Plus, now I'll leave the x alone. The derivative of y squared is 2y, but again I have to tack on this dy dx term, and that's going to be equal to the derivative of 3x, which is simply 3. So sorry, running out of a little bit of room here. Again, now the basic idea is we'll put all of our dy dx terms on one side. So notice I've got an x squared dy dx term. I've got a 2xy dy dx term. So I'm going to just leave those on the left side, recognizing that I should get rid of the parentheses, but since there's a plus 1 in front of the parentheses, I can just basically imagine they're not there anyway. So on the left side, I'm going to have x squared dy dx. I'll have I usually do numbers and then alphabetize just to keep things straight, so I'm going to write this other term as 2xy dy dx. And I'm going to put everything that doesn't have a dy dx attached to it on the other side. Well, my 3 was already over on the right side, so that takes care of that term. I'll subtract over the 2xy term that I had at the very beginning, and then I'll also subtract over the y squared term that I have. Again, now we're basically back to this procedure where you simply factor out the dy dx term on the left side. So I've got my dy dx. I can factor out the x squared plus 2xy, leaving the right side alone, minus 3 minus 2xy minus y squared, and then I simply divide through by what's left on the left hand side. So my final solution will be dy dx equals the right stuff, which is 3 minus 2xy minus y squared, and I'm going to divide all that by the x squared plus 2xy term. And again, there is your solution. If you need to see some other examples of implicit differentiation, I have a ton of videos on my website. I've got close to 100 on there, so definitely some more examples of implicit differentiation. I tend to not post on YouTube a lot because of this 10-minute time constraint. A lot of my videos go into more depth than what 10 minutes will allow, but I am going to start trying to put some more here. Also, feel free to visit Google Video and do a search. You can find tons of my videos there. So if you have any questions, shoot me an email. I'll be happy to answer it, and I hope this helps.